Dear children, today we are going to see a few topics on the chapter Is Matter Around Us Pure? First, suspension. A suspension is a heterogeneous mixture in which solid particles having size greater than 1000 nm are distributed in a fluid without dissolving in it. The properties are: a suspension is a heterogeneous mixture. The size of suspended particles in a suspension is quite large. The suspended particles can be seen with the naked eye or under a simple microscope. When left undisturbed for some time, the suspended particles settle on the bottom of a container under the influence of gravity. Suspended particles can be separated from the fluid medium by decantation or filtration. Now, colloids. A colloid or a colloidal system is a heterogeneous mixture in which one substance is dispersed as very fine particles having size in the range of 1 to 1000 nm in a continuous medium of another substance. The discontinuous phase of fine particles is called dispersed phase and the continuous phase is called dispersion medium. For example, fork, butter, whipped cream, bread, gum paste, jam, jelly, smoke, etc. and all are colloidal in nature. Now, types of colloids. Dispersed phase and dispersion medium can be solid, liquid or gas. Therefore, total 8 types of colloids are possible depending on the physical state. A gas mixed with another gas does not give a colloidal system because gases mix with each other to give a homogeneous mixture. The 8 types of colloids are foam, solid foam, aerosol, emulsion, gel, solid aerosol, colloidal solution and solid salt. Based on the nature of interaction between dispersed phase and dispersion medium, there are 2 types of colloidal solutions. First one, lyophilic salts. The word lyophilic means solvent-loving. Substances like gum, starch, gelatin, etc. when mixed with a suitable solvent like warm water readily form a colloidal solution. Now, lyophobic salts. The word lyophobic means solvent-hating. Metals, their oxides and sulfides, etc. when simply mixed with the dispersion medium do not form a colloidal solutions. Special methods are to be employed to prepare colloidal solutions. Now, the properties of colloidal solutions. Some important characteristic properties of colloidal solutions are: they are heterogeneous in nature. Second, the size of colloidal particles ranges from 1 nm to 1000 nm. Colloidal solutions pass as such through ordinary filters. Therefore, colloidal particles cannot be separated from the dispersion medium by simple filtration. But by using ultrafilters, the dispersed phase and dispersion medium can be separated. Now, Tyndall effect. When a strong beam of light is passed through a colloidal solution, the path of the light becomes visible with a bluish light. This phenomenon is called Tyndall effect. Tyndall effect is due to the scattering of light by colloidal particles. It can be observed when fine beam of sunlight enters into a room through a small hole. Now, Brownian movement. The continuous, random and zigzag motion of colloidal particles in the dispersion medium is called Brownian movement or Brownian motion. It was discovered by an English botanist, Robert Brown, in 1827. Because of Brownian movement, colloidal particles do not settle on bottom of container due to the influence of gravity. Next important property is electrophoresis. The movement of colloidal particles either towards anode or cathode under the influence of electric field is called electrophoresis. The charge on colloidal particles is the main factor for the stability. Due to the mutual repulsion between similar charged colloidal particles, they are prevented from aggregating to form bigger particles when they come close to each other. Now, coagulation. If the charge on colloidal particles is decreased or removed, the colloidal particles will come closer and aggregate to form a large particles which settle as a precipitate. This phenomenon is called coagulation or precipitation. Now, the applications of colloid. Colloids play a very significant role in nature and our daily life. Most of the food items are colloidal in nature. For example, milk, ice cream, bread, whipped cream, fruit jams, jellies, etc. are some of the examples of food items which are colloids. In medicines, the medicines in colloidal form are easily absorbed by the body tissue and hence more effective. Argyrol, a protected colloidal solution of silver, is used in the treatment of eye diseases. Blood is a colloidal solution and the stoppage of bleeding on applying ferric chloride solution is due to the coagulation of blood and forming a clot. Now, purification of water. The river and lake water has colloidally dispersed impurities. This water is treated with alum, chemically called hydrated potassium aluminium sulfate, which causes the coagulation of negatively charged colloidal impurities and makes them settle down, leaving clear water above. Formation of delta. The river contains colloidally dispersed particles of sand and clay, which carry charge. On the other hand, seawater contains electrolytes which provide sodium, magnesium and calcium ions. When river meets the sea, these ions neutralize charge on sand and clay particles which get precipitated and settle down as a delta. Now, smoke precipitation. The smoke coming out from the chimney of an industry is actually a colloidal dispersion of solid particles of carbon, arsenic sulfide, dust, etc. Smoke is passes through a Cortal precipitator. The gases that leave the precipitated are free from smoke. Valuable substances like arsenic oxide may be recovered from precipitated smoke. Now, artificial rain. Artificial rain can be induced by spraying oppositive charged sand and dust particles or silver iodide particles onto water-bearing clouds. The colloidally dispersed water particles present in the cloud will get neutralized and precipitated to form a large drops which come down as rain. Cleansing action of soap. Soap solution is colloidal in nature. It removes dirt particles from cloth or body by emulsifying the greasy matter sticking to the body or cloth. Blue color of the sky. The blue color of the sky is due to the scattering of light by colloidally dispersed dust particles. Thank you.